Hi everybody. Today we're going to be looking at the topic of moving things around in math. So the term that we're going to use for that is transposing. It sounds imposing. No, it doesn't. What it just basically means is, can you solve for a certain variable? So you'll notice in questions I'll say, solve for d, my favorite variable, or maybe solve for a symbol, like pi. Can you apply math laws to these equations? That's all we're looking at. In the challenge section, we'll be looking at simply harder questions where I'll show you a few tricks. Let's get to it.
So we're going to talk about transposing. So solving for a designated letter. So let's take a look at one example. Let's say you had, let's say A, and that is equal to B minus C. And I want to solve for C. Okay, so how do I get C all by itself? First off, a couple things. Realize that this is positive C, so that's going to be really, really important. So let's use our algebra laws and ask yourself, how can I get rid of B on this side? Because I want to get C all by itself. Well, I'm just going to go and subtract B. And over here, I'm going to go and subtract B. Now, some kids like to try and squeeze that minus B right in there, and that's fine. If you can kind of do that really nicely. Now my equation would look like this. A minus B is equal to minus C. All right. Now, common kid mistake says, I'm done. Yay. But this is solving for a negative C. I want to make it a positive C. So how do I make this a positive C? I multiply both sides by negative 1, or divide both sides by negative 1. I like to divide by negative 1, and I divide this whole side by negative 1. And what happens when you do that is it basically changes the signs. So this A becomes negative A, and this B becomes positive B, and this C now becomes positive C. And there you go. C is equal to negative A plus B. It seems a little bit weird to say that, but that's the answer. Let's take a look at some more. What if we had some things involving multiplying and dividing? So let's say we had x is equal to yz. Yes, it's z. It's not z. Over w. And I want to solve for w. So I want to solve for w. How do I do that? Well, gosh, it's down there in the bottom. Well, what am I going to do? Like, how do I get it to be a numerator? Well, you got to go and kind of think about this one a little bit and say, let's try and get rid of our denominators. How would I get rid of a w in a denominator, just for fun? Well, you have to multiply by that denominator. So I'm going to go and multiply both sides by w. So I'm going to multiply this side by w. I'm going to put it over 1. And the golden rule, I'm going to multiply the other side by w. So what am I left with now? I am now left with a wx, and that's going to be equal to, well, what happened over here? Well, when you multiplied both sides by w, that eliminated the w's, leaving me just with a y, z. Okay. Now, I need to make this a w equals. Gosh, well, how do I do that? How to get w all by itself? I'm going to divide both sides by x. And when I do that, I eliminate my x's here, and I leave this the way it is. It looks ugly, but now I have the final answer of w equals yz over x. Yay. All done. Not too bad, right? Let's do a couple more. I think examples are the best way to learn in math. So let's take a look at this one. And this one's going to look a little more complicated. We're going to say a squared is equal to b squared plus 2cd. And then for this one, we're going to solve for a. Solve for a. So solve for the apple. Ooh, apples. Here's my apple. Maybe there's a little worm coming out of it. There's my worm. I've never seen a worm come out of an apple. There we go. All right. So, what's going to happen now? Let's go and start doing some algebra. So I want to get a all by itself. Well, all of a sudden, this is a squared. So a couple things is, how do I get rid of something that's squared? This would be pretty easy, actually. I'm going to just do the opposite of squaring, which is square rooting. If I square root a squared, I just get a. So now a is equal to the square root of b squared plus 2cd. Done. That was easy. All right, next one. And this will be the last example for this section. Z is equal to x over 2 times y plus w. And I want to solve for y. Okay, well, using kind of like our math kind of rules, I'm going to try and get rid of my denominators because I think that's going to be a little bit easier. So I'm going to multiply everything by 2. So this by 2 and this whole side by 2. And what that is going to do is give me a 2z on the left. And that will get rid of my denominator there, leaving me with an x times in brackets y plus w. I'm going to go and distribute. There's a couple of different ways you could do this one actually, now that I'm thinking about it. But I'm going to go and distribute. And that's going to leave me with an xy plus an xw. We still have 2z. I'm going to go and eventually I'm going to solve for y. So I see my y right there, so that's kind of cool. I'm going to leave this term there, and I'm going to go and subtract xw from both sides. Now that's going to leave me with something that looks really ugly, kind of like a 2z minus xw is equal to xy. Okay. Well, I need to get it to say y equals, so I'm going to divide both sides by x, just like this. So when I do that, it's going to say y equals. It's going to be very exciting. And this is kind of what it will look like. Now, depending on your teacher, they may write it a couple of different ways. And this is pretty important. So 2z over x minus xw over x is equal to y. Now, if you have to go and simplify this, you should be saying, like, can I eliminate anything? Well, you could definitely eliminate the x's here, like that. So your final answer would be a 2z over x minus w is equal to y. Okay? And there you go. And that is transposing.
Okay, for our challenge, we're going to be looking at the exact same topic, but this time we're going to be looking at a few tricks here and there that will make these challenging questions hopefully doable. Let's get to the examples.
Challenge and transposing. We're still going to be following math laws. So I think this is very doable challenge questions for everybody. And it's going to involve a lot of ideas of squaring and radicals. So just as a little precursor is we need to know the opposite of squaring something. So the opposite of squaring something is square rooting something. So, for example, let's say I had a question that said, solve for x squared. Sorry, not solve for x squared. Solve for x, just x. So I say, I want to get rid of this square. Like, how do I get rid of an x squared? Well, the way that you do it is you square root. Because the square root of something squared is just the number itself. So the square root of x squared is x, leaving you with the square root of y plus z. Because you still need to follow the rule. What you do on one side, you do to the other. So we're going to kind of play with this idea when we look at our examples today. So what's the first question we're going to look at? Let's take a look at A. Oops. Let's get rid of that one. Let's go to this one. And look at this. A is equal to the square root. There it is again. We were already talking about it. The square root of b minus c over d. So it's all in the square root sign. And I want to solve for c. And I guess c could be for, I don't know, when I say c is for something, I imagine c is for a cat. So here is my cat. And cats have little ears. And I'm not really a cat fan, as anybody can really tell you. I'm more of a dog person. But I understand when people are kind of like cat people. Here's some whiskers. And let's give the cat those scary green cat eyes. So here's my cat. It's got green eyes. There we go. I guess it's happy. Maybe it just ate a mouse. I don't know. I could draw a mouse, but then it's going to get sad. So we're going to solve for c. Let's get back to the math. So solving for c, the very first thing is I want to get rid of this square root sign. So how do I get rid of like a radical symbol? So I'm going to do the opposite. And actually, just let me go and use a different color to make this very obvious. I'm going to go and do the opposite, which is squaring something. And if I do it to one side, I got to do it to the other side. So I'm going to square that. And what's that going to leave me with? A squared is equal to, well, this completely gets rid of this. It's awesome. And it leaves me just with b minus c over d. Awesome. We're almost there. How do I get rid of the d? Well, using all your algebra skills, I'm going to multiply both sides by d. And that is going to leave me with a squared d, that sounds weird, I understand that, is equal to a b minus c now. B minus c. We're almost there. We're going to solve for c. So I'm going to go and subtract b from both sides. I'm going to squeeze that in there. And what's that going to leave me with now? That will leave me with a squared d minus b is equal to negative c. Now, that is not equal to c. That is equal to negative c. So how do I make this become a positive c? I multiply this by negative 1. And that means I have to do it to the other side. Multiply this whole thing by negative 1. What's my final answer going to be? Negative a squared d plus b is equal to positive c. And there you go. The cat is happy. Happy cat. So let's go and take a look at our last example here. And this one is a really neat one. It's got a little trick. We'll talk about the trick right now. It's called FOIL. And that is not tinfoil. That stands for this. Multiplying things together. So basically multiplying binomials together. And actually, let's take a look at I guess I'll do this one. So w plus z. So what happens here? So first, outside, inside, last. That's what it stands for. So the first terms multiply together, the outside terms multiply together, the inside terms, and then lastly, the last terms multiply together. And this all equals, it's going to look weird, an xw plus a xz plus a yw plus a yz. Now there's a special situation where if you square what we call a binomial, this is really the exact same thing. It just means x plus y times x plus y. So the same idea that we just saw. Now there's a really cool shortcut that you can think of though. If you can memorize this, this is one of those things you should really want to memorize. So if you have to square a binomial, the shortcut is you square the first term. So what is x squared? X squared. You have to multiply both terms together and double it. So what's x times y? Xy. And if I had to double xy, how many xy's would I have? 2 xy's. And then you have to square the last term. There. So this goes straight to the answer. That's pretty cool. X squared plus 2xy plus y squared. So this sets us up. This sets us up to do the challenge work today. So without further ado, let's get to it. So the last question is going to look like this. In brackets, a minus b all squared. So that's just what we just kind of looked at. Plus c squared is equal to a squared. A lot of squares. And I want to solve for a. Solve for a. So the problem here is that there's an a there and there's an a there. So we got some work to do. So you see all the squares, you might want to think, well, I should maybe, square root everything. But that's really not going to be the case. Right now, we're going to make things a little bit simpler. I'm going to subtract c squared from both sides. And that is going to leave me with an a minus b all squared is equal to an a squared, minus c squared. Okay, I'm going to go and expand this. I'm going to go and expand it. So I'm going to use that shortcut I just showed you. So a squared minus 2ab plus b squared is equal to a squared minus c squared. Okay, well, this is exciting because now I have a squares on both sides. Sweet. So I can go and destroy both of these because what I do to one side, I can do to the other side. And now I'm left with, not as much. So that's pretty cool. I'm going to go and I'm also going to subtract b squared from both sides. And what does that leave me with? So what am I down to now? I'm down to a negative 2ab is equal to negative c squared minus b squared. Like that. I'm going to divide both sides by a negative 2b and divide this by a negative 2b. And I'll get the final answer because this eliminated the b's, the 2's, leave me with that a that we've been looking for. So a is going to be equal to, and this will all change, and I'm going to kind of rewrite it so it's nice and neat, to a b squared plus c squared all over 2b. And that's my final answer. So there you have it. Transposing with a couple of tricks. You've seen some FOIL. You've seen binomials multiplying by each other. Some really good tips here.
Whew. Okay. Hopefully we've tackled the mountain that is Everest and also the topic of math that is transposing. Hopefully you've enjoyed, you've learned a little bit, and hey, drop me a line and let me know how these videos are working out for you. Till next time.